Okay, this is October 14th. I'm Kim Sung-hyun, and today Jonathan is participant. Uh, the goal of this video is I'm participating in Professor Gunheecho's mathematical program, which is to become a professional mathematician. I'm doing his program from the set theory, and today I will shortly review the set theory with Jonathan, who will become professional mathematician in the future. Set theory, we should define the set theory. If we want to talk about set theory, then we should define the set first. Then I will briefly define the set. I think it is not really a rigorous mathematical definition, but we just define set as collection, or it is also family. And we can say it is definable object. So we can group some element, and we can say element is in the set or out of the set. And we can write or define a set by write each of the element, or we can write the set by writing their condition. And what I knew about is this has kind of it has meaning. It implies this px is just a sentence, but we can use it to define a set. So there is some logical gap between this sentence and defining set. So we should be carefully watch this. So how we can define the set. And there's also power set, which is set of collection, will be from nothing to 1, 2, 1, 2, like this. And there will be set of natural number, and there will be set of integer, and there's also set of quotient, real number, and complex number. I think the good exercise is that if I am right, the cardinality of integer and natural number has same cardinality. Am I right?
Yeah, so natural number, integer, and even the rational numbers have the same cardinality.
Yeah, if I define it, actually I forgot how to do it, but I will. Let me remember the thing. How can I do this? Okay, let's go. If I make a function n to z, and if I say, I'm looking the note right now, but I can't remember it, so I will just write down. Maybe I remember. If I say n goes to n minus 1, then if n equals to 2m, then there is some unique m, which is in natural number. If n is of 2m minus 1, in this case also there is some unique n, which is equal to n. And okay, already 5 minutes is best. I will go quickly. So there is very popular proposition that we need to do is show that square root of 2 x squared equals to 2, x is bigger than 0 is not a rational number. We can use contradiction, so I can get p equals to a equals to b squared plus q squared. Am I right? I'm confusing.
Yeah, so you're
Okay.
doing the
Okay.
proof that square root of 2 is not rational. Yeah, this is a good place to start.
Okay. Then would be I'm using contradiction. So if I say uh, p equals to 2k, right now there's no many time, so I will pass it. I will next time I will show you the proof. And what is interesting thing is I heard I saw the record, and you can directly prove this without contradiction, but you need to know Galois theory and something more. So maybe you can try it next, or can you already do the direct proof?
So Galois theory is where I ended my study into sets at this point. I haven't gone any further than learning Galois theory.
Okay. Then next, wait a second. I'm following on my note. So we also, when we talk about set, we also talk about partial set, which is if A's element A, which is in set A, is a set A's all element is in set B, then I think it was the definition of A, set A is in B. And we talk about the power set, and we will also talk about entire set, which is include set A and B together. And there is intersection, and there is A complement, and then there will be B complement, and there will be also truth table. It's what we talk about here. And there is Cartesian set, which is set of pair of A comma B. And after that, we can talk about the function. Function is when I say A and B, and A is domain and B is codomain. If there is some A, for any A, if there is F A equals to B, then we say that function exists when given to set A, given to set A comma B, f A equals to B is image, and we can also talk about pre-image, which is if we say this is image, then if we gather all the A element that is in set A, which is equal to this image, then we will call this as pre-image. We can also define inverse function by when there is B multiple Cartesian set of B and A, we will say this as inverse function, which is y comma x. The y and x is in each of set B and A. And when we talk about set, we should think about the Russell paradox, which is Russell paradox and paradox of barber. Like barber can't barb their own hair. From this, the category theory and other things come out. So maybe we can, if we go deeply next time, then maybe we can talk about category theory in 4 or 5 years later. This was my brief summary today. Do you have any comments?
So you have a pretty good basis already. Like, this is most of what you need to know going into set theory. The only things, so you have intersection, you have complements. Do you have like I'm sure you know, but I don't think you mentioned unions, like the union of suicide.
Yeah, I didn't mention about union here. How can I? I don't know how to exactly define set, but if I just write it, then it will be X such that it is in A or B, it will be union.
Yeah, so I can't see where you're writing on the whiteboard there. Yeah. A union B is X such that X is or that it would be X is an element of A or X is an element of B.
Okay.
Whereas an intersection would be the and statement.
Okay. And I didn't told about proof. Like there will be quantifier. And, Jonathan, can I use more than 3 minutes? Actually, it is already time is past.
Yeah, that's fine.
That's okay. Fine. Then I will very quickly talk about how to prove because it is related with set theory. There will be proposition, which is we can talk about true and false, and there is formula, and there is predicate logic, which is if we can put some specific variable, so we can tell the truth or false. And there is some quantifier for all x and sum x. Sum will be, it will be like sum x. And if I make very simple truth table, then there will be P, Q, and P intersection, and there can be P union. And if I say true, true, then it will be true, true. If I say true first, first, true, first, first, then it will be first, 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 true, true. And by this quantifier and predicate, we can make more complex logic. Logic is consisted of constant, variable symbol, which is x, y, z, and there will be function symbol, fx, sin x will be function symbol, and there will be relation symbol. It will be maybe x equals to y, or x is smaller than y. It will be relation symbol, and there will be logical connectiveness, which is this kind of something x, some x, or every x symbol. And when you make logical equation, you have term and atom, which is term is object that is constitute of variable, constant, and function symbols. And atom is term plus relational symbols. Formula is atom plus logical connectiveness. So it will be maybe px, then qy, or for all x, or some x and all y, p x comma y, then it will be formula that you can maybe put values and find it is right or not right. And for quantifier, the dependency is really important, which means if I say all x sum y, then all sum y is dependent on all x. If I say all x, then it is for any x. So there it is kind of independent. If I say sum y or x, then all x is dependent on sum y. For me, I was a little bit difficult on distinguish the relational symbol and logical connectiveness. It is also related with proposition and formula difference. So I'm going to distinguish it by simple example. Okay. Today, I think I summarized what I was going to do. And for direct proof of root 2 is not a rational number, you can use group and field and their relations, then you will be able to prove it. Do you have any more comments? I think I need 4 or 5 years maybe to prove in by direct proof.
I don't really think it would take, if you set out with that as your goal, I don't think it would take that long. However, that is a very specific direction to go rather than a broad approach. In terms of a broad approach, you have a fantastic start. I don't think you'll have any trouble going forward.
Thank you very much.
With this summary.
Maybe next time, I think next time it will be again set theory, and maybe I can also talk about real analysis. I'm not sure. Next time it will be again summary of set theory, and some little bit of real analysis will be what I will present about. Thank you so much.
Thank you for having me.